Assalamualaikum. We are from Group 2 of AS2014A2. Today we will be presenting our group project on data classification of our dataset of CylinderBands Dataset. My name is Nur Rabiatul Misha binti Jamaluddin.
My name is Shafiqah Hadirah binti Muhammad Shazalli.
My name is Nur Atikah binti Shahrulzamri.
And my name is Syakirah Atiqah binti Muhammad Rosszi.
In our project, we'll be doing the task of searching the data, understanding and preparation of data, which includes the cleaning and pre-processing and data transformation. And lastly, we will do the data preparation of data reduction. So first is searching for data. Our group has chosen the data of CylinderBands dataset. CylinderBands dataset concludes the dataset for the printers of rotographer printing. So printers are always seeking higher productivity by increasing their production rates and minimizing process delays. When process delays have known causes, they can be mitigated by acquiring causal rules from human experts and then applying sensors and automated real-time diagnostic devices to the process. However, for some delay, the expert have only weak causal knowledge or none at all. In such cases, machine learning tools such as Reka can collect training data and process it through an induction engine in search of diagnostic knowledge. So our objective for this project, our dataset will be helped to apply a machine learning strategy known as decision tree induction to derive a set of rules about a long-standing problem in rotographer printing. The induction mechanism is embedded within a knowledge acquisition system that suggests plausible rules to an expert who can override the rules or modify the data from which the rules were derived. By using the decision tree induction to derive process control rule, this system will let the expert to participate in knowledge acquisition by doing what they do best, which is exercising their expertise in improving the rotographer printing. So for our data description, we get the source of our data from the Bob Evans, Ardonelli and Sons Co. Gallatin Division from Gallatin, Tennessee. Our data is associated with the task of classification, and it consists of two types of attribute, which is nominal and numeric. The related article for our dataset is the overcoming process delays with decision tree induction. This is our data description, where it consists of the abstract and the attribute information. So our dataset is the CylinderBands.arff. There are 540 instances and 40 attributes. And from this data, we can see that our dataset contains missing values. Next, I will pass to Shafiqah for the next task.
Okay, next we will see data understanding and preparation, which is cleaning and pre-processing. This table is actually a numeric attribute for this dataset. We have 24 numeric attributes in this dataset, and this table contains mean, max, minimum, and standard deviation of numeric attribute. Next, we will see how we handling missing value. As you can see here, our data actually consists of missing value. So we have to recover this missing value. How? We go to pre-process, and at first we have to select attribute that have missing values, and then we go to pre-process and click choose, go to filter, unsupervised, and then attributes. We choose replace missing values filter, and then we apply. And then we can see the result is, we can see at the panel, at the right panel, we can see how before, we can see there is a percentage of missing value, but when we apply the replace missing values, we can see 0%, which is we already handled the missing values. Next, how we handling our noisy data. We identify the redundant data, such as data that have same value but different spellings such as lowercase or uppercase. We remove them through Microsoft Excel. As you can see here, starting from data number 504 until about 540, we remove them because they have redundant data. They have lowercase and uppercase data. Yes. And then next, we identify the attribute that we consider as non-relevant to the outcome. So we choose 5 attributes, which is paper mill location, job number, and then customer, cylinder number, and lastly timestamp. After we remove these 5 attributes, our data reduced to 35 attributes only. And next, how we handling outlier and extreme value. First, we will go to pre-process and then choose. We will go to filter, unsupervised, attribute, and then we will choose interquartile range filter and we apply. Next, we can see how the attribute, 2 attributes are added at the this attribute panel, which is attribute 36 for outlier, attribute 37 for extreme value. And then next, this outlier and extreme value have to remove, and the outlier and extreme values will be appeared as yes, and the instances are suggested to be removed. How are we going to remove this? Is by we select the outlier attribute and then we select at this properties, this panel right here, and then we change the attributes index to 36, which is referred to the outlier attribute, and nominal index to large, which is referred to instances for yes. And then we apply. And the result is you can see that at here at this table you can see the count for yes is 0, which is mean we have already removed the outlier value. And then we will do the same for extreme value. After we do the same, and then you can see also here this table how the yes, the count for yes is 0, which is already removed. And next, we will save the clean data with by naming the file with CylinderBands _clean.arff. And you can see here our clean data. You can see there's no missing value anymore. Okay, that's all from me. I will pass to Atiqah.
Now, we will move to the second part of data understanding and preparation, which is data transformation. Firstly, the normalization task. The filter that we use is the normalized filter that can be found under pre-process, unsupervised attributes. Normalized filter refer to normalize all numeric values in the given data set apart from the class attribute if set. The default setting of the normalized filter is the minimum and maximum normalization. The attributes that has been selected for this normalization is only the numeric attributes. The reason of using this is to normalize the numeric values from its different minimum and maximum values into the range of 0 to 1 only. As we can see from the before slide of before we applied the normalized filter, the minimum and maximum values are changed into 0 to 1 only in the after slide. Next, the task of discretization. Discretization refers to an instance filter that discretizes a range of numeric attributes in the dataset into nominal attributes. The attributes that have been selected to be discretized are attributes number 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 29, 30, 31, and 33. These attributes are selected because of its high distinct values. The binning that we choose are only 5 bins. From this slide of before and after we discretize the dataset, take for example the viscosity attributes, we can see that from before we apply the filter, the binnings are unorderly and is not balanced. After we apply the discretization, the binnings is put into only 5 bins and become more balanced. These are more examples of the discretized attributes. As I mentioned before, the bins that we have chose is only 5 bins rather than the default setting of 10 bins. However, I would also like to mention that only attribute 31 has one of the bin with the value 0, whereas all the other selected attributes prove to be suitable for the number of bins implemented. This is because after applying the discretized filter, the vast values of the attributes managed to be balanced and put into order in the 5 bins. Lastly, we save our dataset into CylinderBands_normalize.arff. I will now pass the presentation to Ms. Shafiqah Atiqah.
So next we conduct the model development and evaluations. So for our group, we use a J48 classifier for our dataset. So first, we run the classifier using a cross-validation, fold equal to 10, and the accuracy that we get is 66.4336%. And next we visualize the tree for the folds equal to 10. Next, we apply the cross validations with folds equal to 20. And we get the accuracy of 66.7832%. And we visualize the trees for cross validation 20. Next, when we try to run our data using a percentage split with 70 to 30 ratio, the accuracy that we obtain is 62.7907%, and then we visualize the tree. And lastly, we apply a percentage split by using a ratio of 90 to 10, and we obtain accuracy of 58.6207%. For all the classifier that we run, we get the number of leaf with 77 and the size of tree with 101. Next, this is a tree visualization for the percentage split 90 to 10 ratio. And then we done a data preparations, which for a data reduction. For a data reduction, first we run attribute selections. So we decide to use a greedy stepwise method for our data, and we obtain 6 selected attributes, which the first one is ink type, the second one is type of cylinder, the third one is roughness, the fourth one is press speed, the fifth one is the solvent viscosity, and the last one ESA voltage. So after attribute selections, we can see that all the attributes left is 6 plus with one class attribute, which is band type, and the total attributes left is 7. We can see the comparison between the number of features before and after the attribute selections. So we can see that the number of features, which is the number of attributes, and the number of instances. So for the number of attributes, before reductions, we get 35, while after reduction, only 7 are remained. And for the number of instances, before is 502, while after the reductions, only 286 left. So we received the reduced dataset under the file name CylinderBands_reduce.arff. This is our reduced dataset. As we can see, there's only 7 attributes left. And then we run again the model development and evaluation, but this time we use a reduced dataset. So the first one, using a cross-validation fault 10, we get accuracy of 61.1888%, and we visualize the tree. Next, we use a cross-validation of fault 20, and we get accuracy of 63.2867%, and we visualize the tree. And then we use a percentage split of ratio 70 to 30, and we get accuracy of 63.9535%. And we visualize the tree for 70% percentage split. And the last one, we use percentage split with ratio of 90-10, and we obtain the accuracy of 55.1724%. For all the classifier that we run, we get the number of leaf, and the size of the tree is 29 and 38 respectively. So this is the last one. We visualize the tree for the percentage split, 90% after the reduction. So as you can see, this is evaluation, which is we compare the overall result by using the J48 classifier. So as you can see, other than split 70, the classifiers show a decline in the accuracy, but only the split 70 show an increase in the accuracy. So we can conclude that our dataset are more suitable using a split 70 classifier.
So I guess that's all from us. Thank you.